Howdy do. So I've been working on this project the past couple days and learning a bit of stuff with it. I wanted to kind of explain it. It was pretty fun to make, and I definitely learned a lot about using this joystick and lining up this circuit. So I'm going to try and explain some of it and show a demonstration of how it works, along with the code on the computer. Alright, so I kind of want to explain this the best I can, because that's the best way for me to learn. So I actually wrote out this entire diagram over here, which is probably completely wrong with the orientation and everything, but it gets the job done, I think. And I'm going to try and explain this circuit right here. Okay, so here's the diagram. On the left we have all the inputs and outputs, and here we have the actual circuits with all the components. So let's explain what some of these are. So these things here, these are called transistors. All of these little circle things, I'll explain more about that in a second. Each of these 9 things, these triangles, are the LED bulbs. The little squiggle or sharp marks on the line are the resistors, and I wrote the value of them there. So this one is 1000 ohms, and I think most of them are 1000 ohm, with the exception of this resistor down here, which is 10,000 ohms. This is a button, which you can actually see right here. Is this blue thing, and let's see, what did I forget? At the top here, we have the buzzer. This is the buzzer, and this is what it looks like right there. And so, here are all the inputs. Let me kind of explain what these are. So the 3.3 volt input, this basically is giving the power to the entire circuit. And in order for the circuit to be complete and for the charge to run through it, we need everything to go back to ground. So it needs to be a complete loop. And so I actually have 2 main lines here. This one here, which the 3.3 volt is connected to, is going to be the 3.3 volt line, which is actually this red line. If this will focus. The red line here with the plus sign is our 3.3 volt line. And similarly, the ground line is this whole line here, and that is this blue one right here. So everything will reconnect to it to finish out the loop. Okay, as for the other inputs and outputs, before I get to those, let's talk about the transistors. So the entire purpose of this setup was in order to turn on one bulb at a time, without having to have like a ton of different inputs to each one. So we can kind of choose which path to open up, and it will allow the current to pass through just one of these LED bulbs. So for instance, say we wanted the middle one to turn on, right? In this grid, that would mean that we want the charge to go through here from our 3.3 volts, through here, this line, and then down into ground through one of these. Sorry, here's the line. Where's the line? This is the line. My bad. Through these to get to ground. And so in order for that to work, we actually need the current to pass through this transistor and this transistor. So it's like almost like a position within this grid. We want position, say this is position 0, this is position 1, this is position 2, this is position 0 down here, position 1, position 2. We want coordinate 1, 1 to turn on this middle LED. So what we would do is we would allow the current to pass through each of these. So that's why we actually use transistors, because what a transistor does is it will only allow current to pass through depending on the base leg of the transistor. So each transistor has 3 legs, or most common transistors have 3 legs, and the middle one is the base leg. And depending on if that base leg has a current or does not have a current, it will either let the current pass through it from the 3.3 volts, or it will not. It'll just cut it off, and there will be no charge going through. And so that's kind of the idea here. So that's what all these inputs and outputs are for, in order to turn on or send a current through the base leg of each transistor that we want to open up, so that we open the pathway to turn on the correct LED bulb. So if we want to do this top left one, we would send a current from input output 13 through here to turn this transistor on. Then the current that would allow the current to go through here, and we would also open this transistor down here, which is connected to input output 19. So we send a current through the base leg there, which opens up both of these, and now the current can safely pass through here to ground this line here. And so that's the main idea with this whole circuit here. And then some other components that I'll explain how they're used later. But we also have the button here, which basically is pretty simple. All you do is you press on the button, and it actually just closes, physically attaches these metal pieces so that the current can flow through, and then it will read the input from that button. So it'll read that a charge is happening at the input 39 pin. And the reason for this transistor here, actually, it's you wouldn't really think you need it at first, but it's in order to complete this loop here, to ensure that when this button is disconnected, there's no loose particles of charge hanging around in this pin that will give us a false reading of the pin or the button being pushed or this being closed. And so that just draws it out into our ground rail and completes the circuit. So that's just kind of the reason for that. And at the top here, we also have the buzzer, which you'll see why I included a buzzer. This was actually a late addition in the project. But I added a buzzer which makes sound, obviously, and you can change the pitch of the sound with this transistor, because what this will do is there's a function in the code that will allow you to basically pulse the charge over and over again very quickly through with this transistor with the input output 27 pin, which goes through the base leg of this transistor, and that basically it keeps opening and closing the circuit here for the charge to pass through this buzzer. And what that does is it changes the pitch, because the faster that it vibrates or has the charge going through, the higher the pitch will be, and the slower, the lower the pitch will be. And so that's the purpose of this transistor and the buzzer there. And anyway, you'll see how that works later on. That was a pretty long explanation, but I hope I did it justice for the most part. The extra resistors here are mainly just for safety and to ensure that the current doesn't get too high so that all the LEDs can safely turn on and everything. But other than that, I think that is all I need to explain. So with that, let's move on to the code and see how it lines up. Okay, before we move on to the coding, I actually forgot to explain about these two components. I didn't write them on the diagram just because it'd be more annoying. and I have to account for all these pins and write them down. So I'm just going to try and explain them quickly. So this is the liquid crystal display. Basically, you can use it to display text, which will be helpful for our project. And this is the joystick, which I'll be using as part of this project to actually move the lights around, which you'll see later. But basically, what it does is it reads the amount of current that's being passed through in either direction, and based upon that you can change variables and stuff in the code, which I'll explain in a second. And that's what these wires are reading into these pins over here. And this one, it basically gets powered on and goes to ground, as we explained, completing the circuit. And there's also like a clock pin and another one which deals with the data and what's being put onto the display there. So anyway, that's just a quick explanation. Now let's move on to the code. Okay, so I don't want to go insanely in depth into the code, but I'm going to explain some major things with it. Let me turn the screen so you're not getting blinded by the light. But basically, we have this set up in what's called Platform I/O, and that allows me to communicate with the ESP32 microcontroller, which is pretty neat. Don't ask me how that works. Maybe I'll find out in like 2 years, but anyway. So we had to include certain things in our program. As you can see, the liquid crystal display is one of the libraries that we use to get certain functions for it. And then there's just a few other things which I won't explain, but we talked about the transistor pins, which were these here, which are triggering each of the transistors that go off. That's actually what this is right here. So what I made here is an array of the transistor pin. So I call it the transistor pin grid. So basically when I say it's an array, this is actually a 2D array, and it's storing these values so where I can access them like they're in a grid, more or less. So for instance, if I want to access this value, this is at position 0, 0 in the grid, which I'll show you later on. But that's how I can determine which one turns on. And then I define all the pins and some more details. Actually, I have the buzzer notes, which will be played by this buzzer throughout the project in this program. And these are each the frequencies of these notes. So this is actually the key of F. I think this is lower F. I don't remember which octave. And then it goes up to E. So this is double that, as you can tell, which would be the next octave. 349 times 2. So, anyways, there's a bunch of methods here. Blah blah blah. Let me find something useful. So there's two main parts to every ESP32 program, and that is the setup and the loop, which is down here, right there. And what they're called is pretty much exactly what they do. In the setup, you can set up variables. In the loop, it will literally just keep looping over and over again whatever's in there until you turn it off, more or less. So let's kind of see a few things in the setup. So in the setup, we can specify what the pins will be used for. So each of these pins, you can either specify them to be an input, which is the I, or an output, which is the O. And so basically it'll be saying, do we want to read what's going in? Do we want to read the charge at the pin? Is that going to be an input? Or do we want to send out a charge or current with the pin, which is going to be the output? So for instance, with the button pin, we want it to be an input because we're reading the charge there. But for the buzzer, we're sending out a charge into the buzzer to make it run, so it's going to be an output. So that's just one example there. I made some methods as well, so if you could tell, there were some methods above the where is it? above the setup and the loop. So there's a bunch of like random stuff, it seems like, but really these are things that I'm accessing inside the setup and loop functions, and they help with things throughout this is actually a game. I keep calling it a project, but so for instance, when I first start up the game, the LCD is what I called the liquid crystal display, just to shorten the name, and this is setting it all up and making it print some things. There's also some delays to wait, so it's not instantaneously popping up things. And so those are pretty helpful throughout the program. And so the main part of the program here is the loop, where it's actually performing all the actions for this game to make it run over and over again. And so this is all kind of dependent on our joystick, right? Because we want to take the user input and see what's going to happen. And so that's actually what this is doing here. And we're taking the X value and the Y value of the joystick based upon the position that it's being pushed in. So for reference, typically it would be sideways, but it's just easier because of the way the wires are oriented. The Y axis would be right here, and the X would be over here. Sorry, I said that completely backwards. The X axis would be here, and the Y would be here. So this is Y equals 0 up here. This is Y equals, I believe, 4096. Yes, 4096. And then over here is X equals 0, and over here is X equals 4096. So based upon those, we can actually identify which direction our joystick is pointing, and then change what happens with the lights. So this part is actually pretty important. What it's doing here is we're actually checking to see if the joystick moved to a different light that wasn't already on. And so that's what this if statement is. So basically, if it moved, then we want to set the correct transistors on to turn on the row transistor and the column transistor that we want to allow one of these lights to turn on. And so that was actually specified right here, where we were determining which target row we wanted and which target column we wanted based upon the Y value and the X value received from the joystick. So it's actually pretty cool to see in action. And then you basically just set the transistor on or off, and it will turn on the light. This part of the code is the actual game section, and so it's updating the rounds, checking to see if the round has started. So this is actually going to be a sort of Simon game where you have to match the pattern that it gives you. So there'll be a randomized pattern that it shows, it'll blink the lights in that pattern, and then you have to remember the pattern and press the button when you're on the correct light with the joystick by moving the joystick. And so this is checking the logic for the game, the speed of the game, how fast the lights are blinking, and let's see, what else did I put in here? So this is the section where it's actually displaying the targets. So when it first shows you the pattern, and then it'll write them, turn them off. And I didn't talk about this yet, but throughout the code you may have seen LEDC write tone, and that's actually dealing with the tone produced by the buzzer. So the way I encoded this is that just like the Simon game, each of these lights is going to have its own sound in the key of F, and then if it plays the light, turns on the light, it'll play the sound associated with that light. So yeah, I don't know. I think it was a cool idea, and it actually turned out pretty good, as you're about to see in a second. But that is what it's doing here. It is causing the note to be played at the correct index in that list that I showed earlier, which had the values of the frequencies that will be played by that buzzer. Alright, this is the last section that I'm showing. So this is actually the beginning of the turn for the person to actually select the lights. So it's waiting for the button to be pressed, which is this part here. And so it's waiting for the button to go from low to a high state. So we have a previous button state variable, so where it's reading before it's been pressed and after it's been pressed, and basically checking to see if it changed. And then if it did change, then it'll count that as a guess. So it'll increment the guess index more or less, because there'll be a list of the actual targets that you're trying to go for, and it's going to check and make sure that the one that you selected is correct. And so that's actually what it's doing here, is it's checking the correct guess inside this list called targets, and it's checking to see if the one that you pushed on has the correct row and has the correct column. And if it does not, then this variable fail will be set to true, which basically means that you failed and did not work. You got the guess incorrect. And so if you did not fail, that's what this exclamation point means. And so basically it'll just continue and increment, and it'll keep having you attempt to guess the correct ones until you guess all the correct ones in the pattern. And then otherwise, if you did fail, which is this else statement right here, so else you failed, then it'll turn all of them off, and it actually blinks the light 3 times. So that way you know that you got the wrong one, and it'll beep 3 times as well, and then it'll say end game equals true, which basically will allow this to become true, and then we end up finishing the game, resetting all the variables, and we can actually decide if we're ready to start the next game and press the button again. I also have a score variable, so basically there's a current score and a high score, so it'll keep track of that. And yeah, so I think that's pretty much all I wanted to explain with the code. I didn't go completely in detail, but hopefully it's at a level where you can somewhat understand the idea behind how this works. So now I'm going to try and demonstrate it. So as you can tell, it's a bit difficult to get this entire thing to show, but I'll try and move the camera around. So first we turn on our system, and we get a message, howdy, press the button to play. So, well, press the button, makes a beep, follow the pattern, and press the button to enter a guess. And so now it begins. That is the first one that we need to guess. And so if I move this, as you can see, it moves the light around and makes the beep sound for each one. And then you can actually make your guess by moving the joystick over to that light and hit the button. And it says round cleared, score 1. Round 2, high score 1. So then we continue. I actually did not see which button that pressed, but thankfully I have a built-in feature where if I press the button, it'll actually show me again. It'll do some sort of like weird sequence thing that I kind of thought was cool, but okay, so it was the bottom right, press it, and the middle. Round clear, score 2. So anyway, it pretty much just keeps going until you get it wrong. So let's give an example. Say I got it wrong, right? So I got the right first one, Right, second one. Oh, wrong one. So game over, and our final score was 2. You can press the button to continue, and then you can play again if you press the button. And it starts over with a completely new random set. And that is pretty much the project. Anyway, this was pretty fun to make. I hope you enjoyed the explanation. And this will not be in mass production because it is such a terrible design, but I enjoyed learning it, and hope to make more stuff like this soon. Anyway, thank you for watching, and as always, God bless.